Very good afternoon to all. I welcome all of you to today's session on a CAD/CAM practical. Today we are going to conduct practical on analysis of step bar using ANSYS. We can also make the analysis of this structure. So today we are going to learn how to apply the loads, how to fix the constraints. We can say how to apply degree of freedoms at each end. It means how to apply degree of freedom at the first end equal to 0. That today we are going to learn. Then how to specify the area to this first structure, that is 5 centimeter square, for second 3 centimeter square, and for the third one that is 1 centimeter square. Okay. How to draw these things in ANSYS, these things today we have to learn. Then in the previous slide we have also seen, we are also going to learn how to make the analysis of the step bar. Difference here, the first step is having Young's modulus 2 into 10 raised to 5, and for the second step Young's modulus is different. It means these two materials are having two different materials. And then we can apply some load at the free end. We can call it as P. Then one end of this step bar is fixed. Okay, so how to fix this step bar, how to model in ANSYS. Okay, these things today we are going to learn. If you are having any questions, you can put your question in chat box. We will discuss your queries also. So I think most of the students have downloaded the ANSYS software, okay, in your laptop or desktop. I've already told you in last article, okay, how to download ANSYS software in desktop or laptop. I will repeat these things again. First term students, okay, you have to click on, okay, you can type directly here ANSYS. Sorry. Okay, so ANSYS, you can see on your screen, the one thing is available free student software. So you can download it from ANSYS website. Okay, free student software. So we are using ANSYS student version, not LS Dyna and not electronic desktop students. So now for our syllabus, we are using ANSYS students. In that we can make analysis of mechanical components for CFD, Autodyne, ANSYS Space Claim, Design Explorer. We can make some analysis in that version. You can download it directly from the student website. You can see download ANSYS student version 2021 R2. Okay, so built-in license valid until 31/7/22. It means it is valid for 1 year. The student version is valid for 1 year. Then after that, okay, you will get the next new version, okay, that is 2021, but I am using here old version, that is 19.1. Okay. There is no much difference between this 19 version and 21 version. Just change the element types. Okay, they have added some element types. That is a small change, and there's some changes in graphics. That's it. So all of you know this black screen is the graphics window. It's a main menu. Okay, right side screen is the main menu. This is the graphics window. Okay. This is the command prompt. You can also write the command in ANSYS. Okay, you can write one script and you can paste it in the command prompt. Okay, that script will run the ANSYS file. And when you are making some calculations on the screen, So behind the software, ANSYS is also writing his script. That's the log file. That is called as log file. Okay. You can download it, that log file, you can copy it and you can paste it in the command prompt. Okay. All things will be gets run automatically in the command prompt. So behind the software, when you are clicking on for example, preprocessor, element type, okay. So ANSYS is also writing the same commands in Notepad. That is, he is making the log file. That is a script. Remember these things. Now I will show you now today how to draw the models, okay, in ANSYS. Okay, so already you have learned the analysis of step bar in subject SOM. Okay, the first question here, how to calculate, okay, how to calculate the change in length of the step bar. Suppose I'm applying some force or load here, that is P. Okay, after applying this point, after applying the force P at this point, how much is the extension of these bars? So you can calculate it by using this formula, delta L is equal to PL upon AE. So all things are known to you. P is the load applied, L the length of that bar, A area of the cross section of this bar, and E is the Young's modulus. That is also given. So easily you can calculate delta L1, okay, then delta L2, the change in length of the first bar, change in length of the second bar, and then you can calculate the total length, total change in length, the direction of first and second. Okay, you can also calculate how much stresses is developed in these two bars. How much stresses is developed, that is sigma. The stresses developed, you can also calculate the reactions. You can also calculate the reactions. Okay, so these things you can calculate it already in SOM. So now we are going to learn how to calculate all these things in ANSYS. Do you have any question? Please reply. Okay. Now, if you're having the software, you can also make the steps or do the necessary steps with me. The first thing is very important in ANSYS. There is no need to draw or okay, so I would like to solve this example in ANSYS. There is no need to draw the image or the figure as it is. You can draw it as a line diagram. You have to always simplify the geometry in ANSYS. Okay, you can draw these two step bars as a line diagram. Okay, so you can call it, suppose here you can take this number 1. You can take the second step, you can call this number, I will draw it here. You can draw a line like this one. Okay, the length of this line is from first point to second point is known to you. From first point to second point is 20 mm. Okay, and from second point to third point it is 80 mm. Okay, so you can draw 3 points, 1, 2, 3. So what is the distance between first and second point? 20. The distance between second and third point is 80. So you can draw first of all points only in ANSYS, first, second, 3. That is called as key points. Okay. You can draw 3 key points, first, second, and third. The first key point you can call it at 0, 0, because when you are saying 20, it means what is the assumption? The first point is at 0, 0. Then second coordinate is 20, 0. Third point coordinate is, can you please tell me what is the third point coordinate? Here we are following absolute coordinate system. Yeah, if you are following absolute coordinate system, or the coordinates you have to measure from origin, that is, you can say 100, 0. Because we are measuring the distances from the O point, from one point. That's the reason. We can also, if you are measuring the distance from this second point, you can also write it 80, 0. That is also right. Okay. Now I'm drawing the same points. Remember, first, second, third point. Keep in mind the coordinates of first, second, and third point. Coordinate of first point 0, 0. Second point coordinates 20, 0. Third point coordinate 100, 0. Okay, so I'm drawing the same thing now in ANSYS. Okay, please keep in mind how to draw the geometry on the line diagram in ANSYS. So in ANSYS, okay, in main menu, there are 3 steps are very important in that. In that, the first one, that is called as pre-processor. Someone can ask you what are the basic steps in FEA. Okay, the basic steps are, first one, pre-processing, second one, solution, third one, post-processing. Okay, there are 3 basic steps of FEA: pre-processing, solution, post-processing. There are 3 basic steps. So in pre, what we are doing actually, so in pre-processing, we are making the models, or we can import it. Okay, then we can apply some loads, we can apply some constraints, okay, that we are going to learn. So first of all, I can create a line diagram in preprocessor. The first, I can click on the plus sign. Okay, so there's an option here: element type, real constants, material properties, sections, modeling. Okay, so I would like to model, so you can click on the modeling. You can click on the modeling option, then is the option create. So you can click on create. Okay, what are the options available now here? Key point, lines, areas. Okay, so as you have seen on the slide, we are first of all making the key points. So I can click on the key points. I can say inactive coordinate system. Okay, so I can say inactive CS. I can click on that. Then he will ask you key point number. Okay, so key point number is 1. So what are the coordinates of key point number? X coordinate, Y coordinate, Z coordinate. That is 0, 0, 0. Okay, you can put it 0, 0, 0. All are 0. Then you can say apply. Then second point coordinate. Okay, what are the coordinates of second point? So Y is 0, Z is 0, X is 20. Okay, so X is 20. Remember, I am just writing the X coordinate. Y and Z will remain 0, 0. And I am writing the key point number 2. Then you can say apply. You can see on your screen you have seen the second point. Then you can say third point coordinate, that is 100. So he is measuring the dimension from 0, 0. Then you can say after the last coordinate, you cannot say apply, you have to say OK. Okay, so on your screen you can see three key points. Okay, first key point, second key point, and third key point. Okay, got it? How to locate or how to draw key points. If you want to draw the key point at this position, at that time you can enter x and y coordinate both. Okay, any question? How to draw the key points? Now for this structure, there are three key points, 1, 2, and 3. Three key points, one number, second number, and third number. Okay, now you can see on the next screen, on the next one, how many key points are there? Okay, there are 4 key points. There are 4 key points. Okay, that's the first one, second, third, and fourth. Okay, very good. There are 4 key points. Okay, at that time you should know the coordinates of all these key points. So first one is 0, 0. What's the second point coordinate? Remember one thing. Okay, you have to always use the same. Okay, you are supposing 20. So at that time, what is Young's modulus? What is the value of Young's modulus? What is the value of Young's modulus? Please tell me value of Young's modulus. No, 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 no. E is 207, it tends to 9. It is not the Young's modulus. Remember. Okay, you have to change the unit now. It is different. Listen, when you are solving the numerical, you have to keep in mind one thing. All things should be in same unit. Because when you are solving or when you are solving any question on ANSYS, ANSYS is not asking you which units you are using. Okay, you cannot set the units in ANSYS APDL. You cannot set the units in ANSYS APDL. It depends on you, whatever you are entering the numbers. Okay, so ANSYS is assuming that you are entering all the dimensions in same units. So for this question, you can do one thing. You can either convert this 20 centimeter into meter or mm. Can convert 20 centimeter into mm. Convert all these centimeters into mm. You have to also convert all these centimeter square into mm square. Now right, at that time you have to also convert 207 into 10 raised to 9 PA into MPa. Or you can say Newton per mm square. Okay, then you can match your answer with the analytical one. Okay. If you are doing 20, 30, ANSYS will solve the question. You will not get the error, that is unit error. So he's thinking 20, when you're putting 20, so ANSYS will think 20 is in mm, not in centimeter, because he don't know which units you are using. Okay, keep in mind these things. So in the previous question, all things we have used in mm. You can see 20 mm, 80 mm, 180 mm, 200 mm, and MPa. Okay, so in ANSYS APDL, there is no option. You cannot select the unit types as SI unit or MKS or CGS. Okay, so 1, 2, 3. We have drawn 3 key points here. So after that, the next is you have to connect these 3 key points as a line. You can connect these 3 key points as a line. First, second, and third. We can connect these 3 key points as a line. Okay, the first line and the second line. So how to connect? Okay, so you can connect these key points as a line again in the same option, modeling, create. Okay, there's the option lines. We can click on the lines, then again line arc splines. We can also connect these 2 or 3 key points as an arc. We can click on the lines, straight line. So I'm connecting these 3 key points by using straight line option. Straight line, first to second. Okay, 1 to 2 key points, 2 to 3 key points. We can say okay. So I connected 3 key points by using line. So remember one thing, key point is always connected. Key point is always connected by using the line. You cannot connect the key points by using elements. Okay, you cannot connect these 3 key points using elements. Remember, the key points are always connected by a line. Keep in mind this thing. Okay, so now I've connected 3 key points by using line command. So I have drawn this structure now in line. Now next thing you have to now which things are given as an input? Only lines. Now next thing you have to give the input, that is EA and EA for the first bar and for the second bar. Area for the first bar is 200, area for the second bar is 180. Okay, Young's modulus for this first structure is 2 into 10 raised to 5. It means that is nothing but the steel. Okay, and the Young's modulus for the second structure is 1.2 into 10 raised to 5 MPa. Now you should know how to how to write or how to create the areas and Young's modulus. Okay, so Young's modulus is which property? Tell me, is it material property or real constant or section property? According to sections, for example, some structure is having C section, some structure is having circular section, some structure is having I section, okay, and with the same material. So in that case, is E is going to change. Okay, for I section, for circular section, for C section, okay, with the same material, Is E is different or same? Okay, very good. Is it? This is not going to change. It is same. Okay, so Young's modulus will not depend, okay, on the sections. So you have to always remember one thing. E. E is always you have to written in material properties. E you have to always written in Young's modulus in material properties. Okay, you can click on the material properties. Okay, there's the option material library, temperature units, electromagnetic units, material models. So I can click on material models. Okay, there are some assumptions that already we have learned in metallurgy. Okay, we are using structural member now here. In structural, I am using linear elastic member. Okay, then isotropic, orthotropic, or anisotropic. Which one I am using? What is the assumption here? In SOM, already have solved this question. Which material you have assumed? Isotropic, anisotropic, or the third one? Orthotropic. I think the difference between isotropic, anisotropic, and orthotropic is known to you. Yeah, Rishabh, you are right. What about others? Remember, we are using isotropic material. Okay, when you click on the isotropic, he will ask you EX. EX is nothing but Young's modulus. Yeah, Chetan, you're also right. Okay, so you can put here Young's modulus. So what is the value of Young's modulus in the first case? 2 into 10 raised to 5 MPa. Okay, so I can write here. I can write here 2, okay, into 10 raised to 5. So you can say 2E5. Okay, 2E5. Or you can also write 200 to 50. So what is the Poisson's ratio for the metals? What is the Poisson's ratio for the metals? Poisson's ratio for the materials or for the metals. Yeah, Deep, you're right. Akash, no, it's a very big number you're saying. Yeah, very good, Chetan. Do you know what is the Poisson's ratio in terms of definition? A ratio of what? Poisson's ratio? Yeah, Ankush, you're lateral to the longitudinal strain. Okay, what about others? What do you mean by Poisson's ratio? Lateral strain to longitudinal strain. Okay, very good. Okay, so when you're saying 2 into 10 raised to 5, okay, very good, Ankush. So at that time, he can recognize 2 into 10 raised to 5, it's a metal. Okay, you can put the Poisson's ratio 0.3. Okay, 0.25 to 3, 0.3. You can call it then. Okay. Okay, so you have created the first material model. You have created the first material model, okay, with Young's modulus 2 into 10 raised to 5. Now you have to create second Young's modulus, that is 1 into 10 raised to, sorry, 1.2 into 10 raised to 5 MPa. See, if your structure is having so many Young's modulus, 10 or 20 materials, so you have to create 10 material models. So second material model, you can create it from, okay, the first model is created. Second model, you can click on the material, say new model. Okay, material, click on the new model. The material ID number 2, you can say okay. Okay, ID number 2 is created. Then you can again say structural, linear, elastic, isotropic. Okay, what is the second Young modulus? 1.2 into 10 raised to 5. You can write here 1.2 E5. Poisson's ratio 0.3. Okay, they can close it. Material models are created. One for the first one and for the second one. So any question how to create the material model? Okay, next thing we have to create areas now. Okay, the first bar is 200, second bar is 180. So you can create the areas. Okay, you can create the areas from in sections. Okay, so first of all, you can click on the sections. Okay, link, add. First of all, I will check it. Again, areas, you have to create two areas, one with 200, second with 180. Now suppose there is having third step here. Okay, so you have to create again third area and third Young modulus. Okay, so I can click on sections, then click on the link, then say add. Okay, link section ID, you can put the number 1 here. It's only for identification. You can click on 1. Okay, then section name, and again we can write, for example, square. Okay, if it is circular, you can put it circular. Then link area, how much is the link area for the first step? That is 200. Remember here, I'm not writing mm square, you have to assume it. All dimensions are in mm. Okay, so 200. Then added mass, there is no mass is given. Okay, tension key, tension and compression. So I can say apply. Again, section ID number 2. Okay. Section name, again I can say square. Now suppose second section is having circular cross section, so you can write circular. Okay, link area, how much is the link area? For the second one, 180. अजून किती मारायचे मॅडम तुम्हाला printouts? Okay, now the second one is 180, so you can, okay, suppose you can use this key now, raise hidden. The second area is 180. Then say okay. Now I have created two areas in link. Okay, with section ID number 1 and 2. Now all given data I have entered in ANSYS now. A I have entered, E also I have entered, L also I have entered. A, E, L. So I have entered all this given data in ANSYS. But till I have not given the first area 200 is to the first step and area 200 180 is for the second step that I have not selected yet. Okay, so you have to select the area 1 and E1 is for the first step and area 2 and E2 for the second step. So how to do these things? For that you have to make the meshing, the most important thing in FEA, that is the meshing. Okay, so for that you can click on the meshing. Okay, you can click on meshing. So do you want to add some points here before meshing? Do you want to add some missing terms or missing things before meshing? Bhushan Patil, do you know the answer? What in the meshing means what? Akshay Bodke, Ishan, Dhananjay Jadhav, Harish Athavle, Harsh Bora, Rohit Thorat. Do you know what in the meshing means what? Meshing of these lines 1 to 2 and 2 to 3 means what? Like getting accurate structure, divide body into small parts. Very good, Suhas. What about others? Meshing means what? हे तुम्हाला भरपूर वेळा सांगितलंय, FEA लेक्चरला पण सांगितलंय आणि कॅडकॅम लेक्चरला पण सांगितलंय. मेशिंग मीन्स व्हॉट? इट्स अ टेक्निकल टर्म. मेशिंग, त्याला अजून एक नाव आहे दुसरं मेशिंगला. What is it? In most of the C8 softwares, they can call it as meshing. Yeah, very good. Discretization. Yeah, discretization of the structure into small number of parts. That is called as finite elements. In finite elements, what is the most important step before meshing? If you are doing meshing, you will get one error here. Okay, I will show you. Okay, click on the meshing, mesh tool. Okay, so first question, element attributes. Okay, I would like to mesh 1 to 2 line. Not extrude, Rahul. There is no need to convert this geometry into 3D. If you are drawing the same geometry in 3D, and you're solving same question for 3D and 1D, you will get same answer. Answer is not going to change. Okay, suppose I would like to mesh line number 1. Okay, between key point number 1 to 2. So how I can mesh it? You can click on element attributes. Is option set. You can click on set. Okay, now for line number 1, what is the material number we have defined? That is 1. Real constant set number we have not defined. Element coordinate system is by default. Okay, section number we have defined 2 sections. One is square, second is circular. Okay, the first one is square with the link area already we have defined, so I can say okay. Okay, what is the error you get now here? Okay, please note down this error. Element type 1 is not yet defined. Element type 1 is not yet defined. Use the et command to define this element type. You can put this et command in command prompt, then you can define the element type. Okay, without element type you cannot do the meshing. Okay, first of all, before meshing you have to always select element type. You can select it from pre-processor. You can click on element type, then add. Okay, now define element types, none is defined, so you can click on the add. Okay, now there are number of elements: structural mass, link, beam, pipe, solid shell, a thousand number of elements. You have to choose appropriate element for your question. Now here I am using link. In link there are two options: 3D, finite, STN 180 and actuator 11. Okay, so how to select element type, that we will discuss in next session. Okay, which are the criteria for selection of elements. कारण की element selection चुकला तो तुमचा answer चुकणार आहे. Okay, the element selection will take too much time. Now for this I am using link 3D STN 180. That name is link 180. The shortcut name is link 180. I can add it now. Then you can close this option. Now link 180 is added. Then after that you can use the option meshing, mesh. You can set all these attributes, say OK. Okay, then there's option size control, global, areas, lines, layers, and key points. Okay, I want to control the size of line, so you can click on set. Okay, I would like to mesh the first line. I click on the first line, then say OK. So how many parts you want? Okay, the two options. Either you can put the input element edge length, or you can write number of element divisions. So I can write here 1 element edge length. Okay, you can see on your screen. Sorry. Okay. Yeah, अजून mesh झालेलं नाही आहे. Mesh, after mesh all these points are gets connected. After you can click on the hidden, raise hidden. You can click on mesh. Here is the first line. Okay. Now the first line is meshed. Okay, with the element type. Okay, with the section name, it means with the area and Young's modulus. Now I would like to mesh the second line. Again, click on raise hidden, set. Okay, now you have to change. Okay, what is the area or what is the material for the second step? You have to change it. You have to click on second now. The material for the second step is written. I have written in 2 number. Material model 2. Section number circular. Okay. Okay, I can set the line here. Okay, so I want element edge length 0.5. Okay, I can click on that. Say mesh, select the line. Okay, then now the line is meshed. Okay, so what we have done so far, now we have just model this step bar in ANSYS. Now what is remaining now? We have to apply this degree of freedom constraint at the first end, and at the second end you have to apply some force, or you can say F or P. So how to do these things? You have to click on the again pre-processor. There is the option loads. You can click on the loads, define loads. apply, click on structural, okay, click on the displacement, okay. So there's an option now here on lines, on areas, on key points, or on nodes. So remember, when you're meshing, okay, these lines are converted into elements. Okay, you can click, if you want to check it, you can click on the plot and say nodes. You can see the small dots on your screen. They are nothing but the nodes, okay. And the distance between these two nodes, can you please tell me how much it is? The distance between these two nodes. So already we have defined. Yeah, very good. It is 0.5. The distance between these two nodes is 0.5 for the second element. Okay. What about the first element? The distance between these nodes. Yeah, the distance between these nodes are 1. Yeah, nodes are distance 1 है. या distance इथला 0.5. Okay. जर तुम्ही meshing केलं नसेल, if you are click on the plot, click on the plot, if you are not done meshing, okay, you will get black screen on your screen. You can say again plot elements. So after meshing, always you will get this type of color. Please note it down. It is sky blue color. Meshing केल्यानंतर प्रत्येक स्ट्रक्चरचा कलर हाच होऊन जातो ANSYS मध्ये. APDL मध्ये I am talking about the APDL. That is sky blue color. After meshing, इथून तुम्हाला कळतं हा पार्ट meshing आहे की नाही. Okay. Now I have to apply boundary constraints. It means I have to fix this end. Okay. So I have defined this end with the key point number 1. So I can click on displacement on key points. You have to click the first key point. इथे येतं लिहून key point number 1 selection इथे लिहून येतं key point number 1 get selected. Key point number 1, say OK. Then you have to define degree of freedom to be constrained. All degree of freedom UX, UY, UZ. हे आपण डिस्कस केलंय. रोलर सपोर्ट असेल, रोलर सपोर्ट सपोज. Okay, horizontally. So UX is open. Okay. So for the given structure, all degree of freedom is constrained. So you can click on all, apply as constant value. So what is the displacement value? 0. He screen the blank असेल, the value is by default is 0. You can say OK. Okay, now the first end or the first key point having degree of freedom 0. Now I have to apply the load at the third key point. Okay, if you want to check the key point numbers, you can click on plot controls, numbering, key point numbers on. Okay, 1, 2, and 3. Okay, now you have to apply force at node number 3. So you have to click on the structural again, then force on key points. You can click on the key points. Okay. Then I have to apply the force towards X direction positive. So I can click on Fx. Okay, I can put the load, for example, 2500. That is Newton. Okay, you can see the load is applied. Okay, now pre-processing work is done. Yes, I come sample pre-processor. So then you have to click on solution, solve, current ls. Okay, you'll get this screen. Solution is done. Okay, I'm just showing you the answer now. Now in third, post processing, click on that. plot results, control plot, nodal solution, degree of freedom. That these things we will discuss in next lecture. Okay, the maximum deformation is on the right side at the free end, and the minimum deformation is on the fixed end. If you want to see the animation, you can see, you can click on the plot controls, animate, deform shape. You can see on your screen. Okay, how to plot all the results in post-processing, that we will discuss in next session. Okay, now you should know how to draw, okay, the models in ANSYS, how to define Young's modulus, area, okay, and which units ANSYS is using, okay, unit systems. Is it SI, CGS, or user defined? Okay, that you should know. Okay, how to select element type, how to apply boundary constraints. Okay, I have applied boundary constraint at the first end and at the free end. Okay, thank you very much for attending this session on ANSYS.